Hello, everybody. Welcome to Drunk with Questions, the talk show where ordinary people talk about extraordinary topics. I'm your host, Gooch. With me today is the only brown guy that fell into the frozen Lake Michigan. Raj, how you doing today?
Oh my God. How many near-death scenarios are you going to just expose to the world? Yeah, so that was an interesting experience. We both fell in, actually, if I remember.
I was saving you. That's
you were
not fair.
balls deep in Lake Michigan in heavy ass clothes. Just okay, so we are in at the shores of Lake Michigan. We just see that for those of you that are not from northern countries or northern regions where snow is readily available, we do have gigantic lakes around us where we live in Michigan, and they freeze over during wintertime. So sometimes you make the right choice and you walk across them. Sometimes you make the wrong choice and you sink into the bottom of the lake. So this time we were rolling the dice and we survived. So it was fun times, guys. So now that Mike is done absolutely destroying my life again for another episode for your amusement, we're going to go ahead and talk about space. I think I can speak for all of us that we are all huge nerds when it comes to space and everything.
It's the only
else
thing my planet lives
cosmos.
in. I have to like it.
We don't have a choice, so we can't go to another planet yet. So we're gonna have to just look through our telescopes and use our science to decrypt the mysteries of space. So we wanted to take an episode to talk about this subject because I feel like a lot of people out there are also very much like us. None of us have a astrophysics degree, yet we are all avid listeners of people that have degrees, and we follow the science behind all the discoveries that's going on in the world in space, and we wanted to talk about it. Just a bunch of normal dudes talking about space.
Yeah, I'd like to think that there's two types of people out there, people that are oohed and awed and maybe even afraid of how space is, and then there's flat earthers.
Yeah, we don't talk to those guys. They're like the gingers of the science community.
Oh,
Damn.
God.
Oh. Read
Shots
the room,
fired.
Raj, Lord.
It's all right. Tim's a flat earther, if everybody's wondering.
No, the Earth is like a donut.
Tin hat and all.
Yeah, he's all about the flat Earth conspiracy. Those chemtrails, that gets him hot.
The
Go
birds
deeper,
aren't
man.
real either.
I'm a hollow Earth believer, man.
But we'll, oh man,
All the dinos are just beneath our feet.
We're gonna keep digging until we get to the core. Dwayne the Rock Johnson told me so.
Okay, so on that of the core and all that, who has seen the movie The Core?
It was on my recent watch list on HBO. I have not actually seen it.
Is that an older one or a more recent one?
It's older. It's
where they dig to the core with the actual machine.
And they have like,
but for the whole thing behind it is that there's like super, the Earth's core stops spinning so that the magnetic fields that protect it from solar flares and radiation starts deteriorating, and so. And I know actually currently we just went through a cycle of some kind of solar storm. Did anyone else hear about that?
Well, they've been monitoring sun flares that have been coming, and basically apparently had to do with something like there was a solar flare on the side of the sun that was so gigantic and so immense in power that if it had come across Earth, it would have just wiped the ozone clean off a side of Earth. So.
But apparently we just currently in like the last week went through a solar storm, and it wasn't, obviously it's not some world ending catastrophe, but I can say I spent last week out in the sun, and I spent 3 days out in the sun. My neck got a little sunburned being a ginger and all, but then there was one day where I was outside for like 30 minutes and the back of my calves burned. Everything else had like burned across a couple of days, but it was like in minutes, the back of my calves burned.
That just sounds like white people issues.
Well, yeah, but you got to think, was it just because that day I was in shorts all the other days too?
I don't know. I remember they were saying you could see the Aurora Borealis here.
Yeah, which is then.
That's super rare. Yeah, this far south of the pole.
That's all just solar interference with the ozone.
Listen, stop
Mhm.
projecting the love from the sun. All right, it's just trying to let us know that it's there.
Just accept the burn.
It's a little
Well,
overbearing,
no,
but
A
it's
little
okay.
love tap
I
from the
kind of
sun.
don't have a choice in that one. Neither does Tim.
Nope.
We're just sun-kissed children.
God blessed me with great melanin in my skin. And
Drain children more
yeah.
like.
you guys
Oh.
are just trying to like you're like absorbing every spot of sun that comes in, just
Dude, it's
destroying your skin.
I can say I've
Yeah.
had sun poisoning a few times. Mike, you've been there with me when I got like second-degree burns on my legs.
Mhm.
Oh God, that's horrible. So like
I
every single time you go outside, you're basically just gambling.
yeah, I'm just absorbing.
How's the sun gonna kill me today?
Yeah, I literally just go outside and
It's-
absorb cancer.
So if we do get hit with a solar flare, like you're just gonna die. There's just
Oh yeah, I'll
Well,
just shrivel up.
no, that's not the one that you're
Yeah.
talking about. Yeah, probably, but really, a bad solar flare, in theory, uh, worst case scenario would just be like an EMP across the world.
Really?
It could knock out satellites.
Yeah, so
Or
like,
fry
I'm not saying
satellites
it's not a bad thing. Of course, it would be really bad, but most solar flares, like decent sized ones, they wouldn't kill you, the population. They'd just set us back probably 20 years.
yeah, but if it's powerful enough to create an EMP, the radiation would alone do a decent amount of damage.
Well, yeah, you'd
to
probably
Earth,
get
yeah.
burned, but like it wouldn't demolish the human population. Bro, the Earth's been around for so long, and not a single solar flare has been attributed to a mass extinction event.
That we know of.
That we know of, sure, but also the ozone is not as strong as it once was. So we are dealing with ozone layer that, dude, think about this. In the 70s, they had to control hairspray because hairspray was causing too much like released of gas into the earth and messing with the ozone. This was
Yeah.
an actual thing that happened apparently.
That was theorized. There's no specific science behind it. Because now they said that the ozone layer or the hole has closed.
Yeah.
Or is near closing.
Well, that's because they controlled whatever substance it was in those. It's not allowed to be in hairspray and all the materials anymore. Like people used to just walk around spraying hairspray everywhere. Just spraying their hair, just randomly, no problem, just in the middle of everything. Like it was just a normal thing for them. I forget the actual chemical it was that was in hairspray.
Dinosaurs used to fart.
I don't know. I don't know if that can
It's
necessarily be.
chlorofluorocarbons.
Yeah, I don't know if that could be enough. If you think about us, we are like just tiny specks of dust in comparison size to everything. And to
Wow,
try
we're already moving
and
into this. All right.
associate that amount of chemical during however long that they were using it would have ripped a hole in our protective atmospheric layers.
Yeah, but we're talking about
That's
chemicals that
speculative.
don't exist in normal time. These are man-made chemicals that the Earth has never come in contact with before. Like we made it for a purpose and we were using it for a purpose and we're releasing it. And it wasn't just used in hairspray too. I think it was used in like AC units and like all kinds of stuff that was available at that time. So I mean, we have a lot of effect on the Earth, even though we are small. We have a large congregation of human beings. The mass of all the human beings on the planet is enough to make a difference to what's going on the Earth. So each individually, yes, we don't matter all that much, but as a collective, it could be a huge effect.
So saving environmentalism for another episode.
Yes, we were about to go down this rabbit hole. So I had some questions regarding you guys just to discuss about space. And one of the first ones I wanted to talk about is probably a deeply controversial topic when it comes to should we be spending money on space exploration? Is it important?
Yes.
Explain. Why do you think it's important?
Tim first.
About why I think it's important.
Yeah.
See, that's where I'm kind of at like kind of a middle ground on it. I think it is important because it expands our knowledge of what's out there through the variety of studies, especially that they've been able to do on the space station. a lot of our technology that we use today was essentially founded in space. Everything from like telecommunications to radios to even specific materials that make up things through that we use throughout our daily lives have been tested in space. So I think gives us a lot of opportunities to further advance in an environment that we can't really replicate the same here on Earth.
Mm-hmm.
Then at the same time, I feel like there are a lot of other things that we could spend that money on here on Earth.
Mm-hmm.
Yeah, because I mean, space are like, all right, cool. We sent up another rocket, and I think someone down the line listening to it's like 30, like essentially, commercialization of space flight. So they estimate the cost at like $37,000 a night, right? The amount of fuel that it takes to get up off the Earth and into space contributed to the variety of life-saving systems that you need on the space station to make sure that people just don't die while they're up there. So I think it's extremely expensive. And I mean, you think $37,000 a night.
Okay, so like the cost is the biggest thing that I feel like a lot of people talk about when it comes to space. And so really it's for us to decide as a human species whether or not the cost of being able to travel to another planet if necessary is worth what is going to be charged. Because right now it's going to be expensive. Because
yeah.
even though we've gone through multiple stages of travel into space, we're still in the infancy of space travel. We haven't even cracked the ability to travel to another planet and come back and still survive. Like that's just not a possibility as of yet. Just because that amount of time in space would most likely kill us or make us unable to even come to the planet once we come back. So, but eventually, I feel like if we're going to do this, we're going to want to see. The thing about space travel for me is I don't think it'll ever be successful in a planet that is divided as Earth is, because I feel like to truly be like a space age civilization, we first have to be a planetary civilization.
So I'm going to say two things based off of what you both just said. So we as humans, as a species, are at this very interesting point in time where we can actually prevent our extinction, even on a planetary scale, by going to another planet, right?
Mm-hmm.
So if there's humans on multiple planets and one dies, humans are no longer extinct. In theory, you could, and this was never even like a possibility until recently, you could, in theory, make a population that is basically extinction proof, other than from like some sort of mass universal genocide or plague or whatever. Even if there was a plague, if you got two planets and one planet gets the plague, you just stop people from coming. You know what I mean?
Yeah.
Yeah.
So,
So
go ahead.
it's a contingency to
Yeah.
extinction is the multiplanetary species model.
Well, I believe so. I
Okay.
think that's really what the goal would be. So that's kind of like the next step in a species evolution is, can you make yourself as difficult to go extinct as possible? But in the vis-a-vis, I guess, of that, we are also at a point where we have to make a decision. Do we continue to blow all of this money in these infancy stages so that we can learn? Because what's nice is when you're in the infancy stage, you can learn a lot from like one thing, one trip, right? The more and more complex you get, the harder it is to learn new things. Uh, but we are learning a lot with these tests and whatever now.
Mm-hmm.
So do we continue doing that and kind of cross our fingers and hope that we reach a point where we're like, okay, we might be able to start getting people out of here? Or do we just recall all of that and focus on the planet that we are on currently And that is kind of a tough choice. It really is. As much as you want to be like, hey, we've been here our whole lives. This is where the species started. We should protect it at all costs. You're also given like that little shiny node that everyone wants to go to. Like, ooh, possibilities. Adversity breeds innovation, right? So we're in an adverse situation. People are saying the Earth is dying.
So let me play devil's advocate here, because I know, I don't necessarily believe this, but I think it's a fair point that people bring up. All the money it would take for us to split the civilization into two, and all the resources it would take to terraform another planet to be habitable for human beings. With that kind of resource, wouldn't we be able to stop anything bad from happening to this planet, or stop extinction events from happening to this planet?
It's a 50-50, right? There's things that you can't control. Like, I don't even think advanced civilizations that are more advanced than us can really control, let's say, a black hole, right? Let's say a black hole changes trajectory for whatever fucking reason and starts heading towards Earth. I mean, you're boned. There's the theorization that, the scale of interplanetary species and how like advanced they are, that you'd be able to harness a black hole and use its energy, which that's pretty high up there. I think it's the fourth stage. The fifth stage is like you're combining stars and harnessing their energy. It's pretty insane.
Yeah, because right now we use fusion reactors for a lot of stuff, but now they've started doing fission. It's become a reality now, where it's basically what the sun does.
Yep.
So without any of like the waste that you would get from nuclear fusion. So that's definitely the next step in energy for us. But it's just, I brought it up. There's some few astrophysicists out there that have brought up the idea that, because I believe what was the gentleman's name? The one that was in the wheelchair that had the
Stephen Hawking.
Stephen Hawking's was definitely a proponent for the multi-planet species.
So I think that's the next step, Raj. It's actually, I'm glad you segued into that. So I think nuclear engines is the next step. Being able to reduce the size, but maintain the power output. That's going to get us to go faster, longer, more sustainable, right? Obviously bad things can happen, and they will, right? Just like on the nuclear submarines when they first started, bad things happened.
Yeah.
But we'll get better because of it. You learn from it. And unfortunately, people will die from doing that. But that's the next step, a nuclear engine. Something that we could literally go up there, bring it back, whatever, continue to use it. That's going to save you a lot of money in the long run. They just got to figure out how to compact that. Also, the next thing would be starting to really break into that like percentile of light travel and what human bodies can actually sustain, right? So the theory is nobody really knows what the human body could actually sustain as far as light travel is concerned. Like what percentage would kill you? I was listening and they were saying that all physicists are pretty sure that traveling at light speed is A, impossible, and B, would kill a human, even if they were comfy or whatever, or in a like suspended in a fluid. And so that's what a lot of them are saying, is that humans, our bodies, in the infancy stages of reaching a percentile of light speed, so 2, 3, 4%, that we would probably have to encase put ourselves in some sort of a fluid stasis that could absorb the shock of doing that. So how do you, and that's questions for people way ahead of us, obviously, but
yeah, that's a very interesting question for me, because I feel like so the speed. So is it necessarily the speed that you're traveling that kills you, or is it the acceleration to that speed that kills you, right? So if you're on a plane, you feel that acceleration as it goes up to 300 miles an hour. But once you hit 300 miles an hour, you're just sitting there. You don't feel anything. It's why I don't believe in warp drives and things like that, because like just going from 0 to even a percent of light speed, that G-force was enough to basically kill you.
I think warp drives, though, are more of a like that whole what they did on
are you talking about the paper being folded?
Yeah, I think that's more of a warp drive.
But wouldn't that be just a wormhole? machine then? You're just
Technically.
creating a wormhole? Because when you look at warp drives, they're just traveling faster.
Well, that's for movies. When I think of
Yeah.
a warp drive, I'm thinking more of a wormhole effect where you're folding space to you, and
Mhm.
you're just able to go to that point.
Mhm.
But here's the thing, though, about speed, right? The space station is traveling at approximately 17,500 miles per hour. There
Mhm.
are no G's once you get into space.
True.
G's
So-
don't exist outside of a planetary atmosphere, essentially. Like every planet has its different gravitational force, but when you're in the void, there's not gravity, there's nothing pushing against you. And that also relates back into one of our problems with, doesn't matter what type of engine, it is just acceleration in general, right? On Earth, it's easy to accelerate a rocket going up using like a nuclear power source or the hydrogen and oxygen, nitrogen, whatever combustion source that they're using, is because you have something to push against.
How fast was it going again, you said?
It's going approximately like 17,500 miles an hour.
Miles. Do you know how many that is in meters per second?
No.
I'm sure
So-
we can convert
So
it.
here's an interesting fact. So I was talking about like 4 and 5% of light speed.
Mm-hmm.
5% of light speed is 14,989,622.9 meters per second.
It's like just a gigantic number.
So, all right, 17,500 miles per hour is 7,823 meters per second.
So double that is 5% of light speed.
Yeah, I think it
It's
would be
fucking fast.
completely potential because there's nothing pushing against you. I mean, you think about it, the astronauts are just floating
Yeah,
in
but here's
zero
the
gravity.
yeah, but it's zero gravity, but it's the shift from going from one speed to the other. Even though there's no gravitational force, a body at rest stays at rest until exerted by an outside force, in which case it would be the thrusters pushing you forward. So your body is set at a certain speed. You quickly accelerate to another speed. You're still going to feel the effect of that acceleration. You don't need something pulling you back because the natural law of the universe says that you're going to be in a rested space until acted on by a force.
Oh, what the fuck?
What?
The conversion is 33,530,831 miles per hour.
Jeez.
That's insane. That's like, I can't even comprehend that amount. 33 million miles per hour.
Yeah, that's
That,
it's
I
a, it's a
mean, and that's 5%. That's 5%.
Yeah.
5%. So
See,
for
I
me,
think-
like you look at that figure, and if you want to travel in space at high speeds like that, you would have to do it gradually, and you'd have to do it to the point that's inconceivable for the person that's actually experiencing the
It's almost what you would need to do. It's kind of like how they got Apollo 13 mission back to Earth on such low fuel, is using like a slingshot method. They use it for almost every other spacecraft that has launched more, I would call deep space beyond the distance of the moon, right?
Yes.
So you launch it, it orbits a planet and it launches off, and it orbits another one, launches off.
Well, the idea of the slingshot was created by a Russian scientist. And it was created like back during World War II, World War I or World War II, that era. And that idea only resurfaced when someone discovered one of the books that he wrote when they were working at NASA.
Yeah.
So the slingshot idea is it's just a smart way of doing it, because we're using the force of gravity on Earth to catapult
pull.
us. But that initially only gets us off of the planet. Once we get off the planet, we have to maintain that acceleration, right?
Yeah.
Because
see,
even though there's nothing acting on you in force, if you go past a planet or something on your journey, you're going to feel some kind of force disruption.
Yeah, but once you get beyond like a planetary system where you're just in the vacuum of space, beyond the reaches of any type of gravitational pull, right?
Mhm.
So let's say you get outside of our solar system, you're outside of the pull of the sun. You get outside of our Milky Way, you're outside of the pull of the star at the center of it. And then let's say you're between galaxies. What's there? I mean, there's probably going to be some type of push-pull against other galaxies because everything is rapidly moving, but you're still going to need some type of back force to push against.
Well, yeah, because what happens is people say the vacuum of space, but here's the thing: they've discovered using mathematics that there is a force outside that we can't
Yeah,
classify
it's like the dark matter.
that's pushing.
Yeah.
So you have a push and a pull that's happening constantly. So even though you're in the vacuum of space, it's not like there's no force that's going to affect you once you get into space. You're just going to keep going. There's forces out there that will push and give you resistance. So you have to be able to fight that.
If we could travel 1/10 of the speed of light,
Mm-hmm.
we could beat a Pluto in 46 hours.
1/10 the speed of light. I mean, nobody's trying to get to
Yeah.
Pluto. Pluto's not even a planet
No,
anymore.
I'm just saying how far away it is, though. It's
Yeah, of course.
3.1379 billion miles away. If we could travel 1/10 the speed of light, we could be there in 46 hours.
Pluto
So
will always be a planet.
here's
No,
what's
Pluto's
interesting,
not a
though,
planet.
because I was reading this. The faster you go, the longer you have to brake, right? We all
Yeah.
know that. That's a pretty basic thing. It also applies to space. So if we wanted to go to Andromeda, right? Let's say. I was watching this show. They were saying that from here to Andromeda would be a 7-year journey for the people that were on it, and it would be about 9 to 10 years for the people on Earth. Okay.
Mhm.
You would only be accelerating for 4 years. You would have to be braking the rest of the time to come into Andromeda at a decent amount of time. Also, another interesting thing, when you're talking about something that's that far away and they're actually getting further away from us, right? That time frame, you actually have to overestimate. You actually have to be like, all right, you're going this far, but you're actually going to have to go this far because once you get there, it's actually moved away from us.
Yeah,
I
because
mean-
we're calculating it to where it's gonna be. So like think about this. The people
Yeah.
that took us just to the moon, had to calculate almost most of the calculations had to be done by hand and checked by a human being. Like computers were a new thing. I mean, we have more processing power in our cell phones than they had in all of NASA
Yep.
to do these computations. And they were still able to figure it out using mathematics. So it proved that the principles of Einstein and Newton and all the mathematics that has shown this is what's going to happen is correct. But it's still hard for us as humans to understand what's going on in the outer reaches of space. Like the distance between us and Andromeda, you'll look at a picture and it's just like, oh, it's just like right there. No. Like how many light years away is Andromeda from us? It's a decent
Yeah.
Andromeda to Milky.
2.537 million light years.
So that so that's it would take us 2 point how many 2 point
Oh no, they were just saying if you could travel it in 7 years. I don't even know how long.
you can't travel it in 7 years if it's that many light years away. That would mean that if you're traveling the speed of light, it would take you 2.7 million years to get there. So it's beyond our scope of what we can even do. That would be a trip where you get a bunch of people together and you said, okay, you're just gonna make babies and you're just gonna keep populating the ship over and over and over again. And your great grandkids, which will most likely not even be humans anymore after evolving in space, will be the creatures that'll land on another galaxy. Like the
good news is
immensity.
that one's getting closer to us, though.
Yes, eventually it will crash into the Milky Way and form another galaxy with the Milky Way.
So we might be able to get over there at some point before it crashes in the Milky Way as it gets closer. So
If it's 2.7 light years away from us and it's traveling towards us, it'll probably impact us in 2.7 light years or 2.7 million years. So
yeah,
we're talking about something that's by the time you get there, it's already right next to you.
well, and that's the thing. We don't even know what's on the other side of the fucking Milky Way galaxy. I mean,
No.
there's plenty of planets in the Milky Way galaxy that we've identified that are actually habitable, as far as we can tell, or close to it. I mean,
So here's a great
fuck
quote.
ton.
Jeremy Clarkson. Speed has
BBC
never
for-
killed anyone. Suddenly becoming stationary. That's what gets you.
Yep.
Yeah, that's basically it. Speed itself will not kill you because you'll eventually adjust to it. But man, Inertia is a bitch.
Yeah, like falling doesn't kill you.
No,
Landing does.
like in terminal velocity, and when you're falling from that guy that fell from the
Oh yeah,
space,
the Red Bull guy.
yeah, gravity's taking you 9.2 meters per second.
Yeah.
9.2 meters per second is the speed of gravity. So, I mean, he survived that no problem. So, like, I feel like we can survive speed. It's just how we decide to get there. But like, how do we even like? They just, I think NASA just did the. Have you heard about the project where they're doing these like microchips that they're sending out into space with light sails?
Yes.
Where
Oh,
they're
yeah.
launching it and then they're just shining a beam of like concentrated light at it, and that's catapulting it to like some fraction of light speed, because it's like our only hope of ever like seeing what's going on in another part.
I just think you should have realistic goals if you're going to talk about traveling light speed, right? So 10%, that's a realistic goal. Like, it's fast, but it's something that we could probably achieve. The question is, could humans survive it? Also, if you could go 10% and you could literally get to Pluto in fucking 46 hours, that's pretty killer. I mean, that's hauling ass, you know? So, like, I think something like
Yeah.
that is what we should be focusing on. In no point in time should anyone be like, hey man, I'm going to go for wormholes. Like, save that for somebody else. Just focus on getting your speed up and making humans survive it. Because getting to Pluto in 46 hours would be killer. That means we could literally get to another solar system probably in a couple years.
Yeah,
You know?
I mean, we think about we talk about black holes and we're like, these are massive, super massive stars that imploded on each other
Yep.
with such a violent force that it basically tears a hole. Like, this is not something you can make in a laboratory.
What
Okay,
fucking scares me is that there's black hole. There's the one in the center of all galaxies, right? That's
Mhm.
what everything's getting drawn to. Which, all right, whatever. But then there's like roaming black holes.
Yeah.
Black holes can just kind of appear out of nowhere. A star could, in theory, just collapse and become a black hole decently close to us.
Our
Yep.
sun could
Yeah,
Yeah,
we
but
got time though.
eventually.
by the time the sun becomes a black hole, because what happens in stars is as they're getting close to dying, they actually expand and they become so
Yep.
large. We are in the radius where the sun expands before it turns into a black hole. It'll eat the Earth.
Yeah.
So we'll burn to death before we worry about the black hole. Like, that's not a problem for us. But in terms of a black hole just roaming around, I feel like it still has to follow the rules, because even though a black hole is an anomaly created from a star imploding, it would still be subservient to the larger black hole in the center, right?
But they're hard to see. That's the problem. So, like, I was watching this fucking like disaster story thing, and they were talking about that possibility. It's like you can't see a black hole. We know that. What you can see is what's going on around it. And they were talking about like how by the time you see a black hole like affecting change on something that's within our within a reasonable time frame of observability, because obviously we're seeing light from stars that are probably dead. Hopefully most viewers know that. A majority of the stars that you see in the night sky are probably already dead.
They're ghosts.
They're ghost light, literally. So by the time you see a black hole affecting change on one of these, it's too late. And that it seems like, oh well, we would still have like a million years. 50-50.
Nah, because how long would it take for us to get to a point where we can actually defend ourselves against a black?
No, black hole, you'd be done.
Yeah.
You're basically trying to escape the other direction is all you're trying to do when you come in contact with something like this. Like,
our focus should be asteroids and solar flares. If we can survive those, we're doing pretty damn good for a global society.
yeah. I mean, the chances of us coming in contact with a black hole with the immensity of space and the immensity of planets and stars out there is probably pretty low.
Yeah.
Because generally, a black hole is not an infinite thing. It doesn't last forever. Eventually, it does go back to just being empty space, and then all that energy gets recycled into a new star or something else.
Right.
Like, yeah, the universe doesn't waste that energy. So,
oh, and we were talking about solar flares earlier. and you know how it could like EMP the Earth?
Mm-hmm.
It could actually flip the poles, which would actually be worse because then a lot of things would be messed up, like compasses and everything.
Mm-hmm.
That's a worst case scenario, but again, that doesn't kill you. Like
Mm-hmm.
it sucks, it sets us back as a species, but we would recover. I mean, you just do everything, it's stupid to say, but you do everything opposite.
Scientists have actually calculated that we're within a time frame for a pole shift.
Yes. Yeah, because apparently it's a naturally occurring phenomenon where the poles do shift
Yeah.
over a period of time.
Was it the Nile flows from south to north, and they attribute that to its reversal of course when the poles shifted. So I believe it's most rivers flow from north to south, but the Nile, I believe, if I remember correctly, flowed the opposite direction.
So they're saying it'll cause calamities such as floods and tectonic events or rapid climate change.
Mm-hmm. Yes. So here's the thing, like
It's a
when
topic for another day.
well, just because the poles shift doesn't mean that the electromagnetic barrier around us just disappears. Like this happens over a period of time.
It'd
And the
become
whole thing,
chaotic.
it'd become chaotic. Like it'd be hard to navigate using any kind of magnetic based thing would be very difficult for us to do. But like it's not like all of a sudden it's hard for me to believe that all of a sudden like the winds will stop and the water currents will change, because the currents are actually not decided by the magnetic polars. I believe that currents are decided by the salinity of the water. So
And
like when you
or like waves are controlled by the pull and push of the moon and the sun.
yeah, it's not actually, so it's actually crazy. I was watching a show about it. When you think of the tides, we think of like the water coming in and a water coming out, but actually what's happening is the waters are pulled and steady at the same point because the sun and the moon are there. What's happening is the earth is actually spinning inside of that pull. So when we see water coming up and down, it's actually the earth spinning within that two bulges of water, because that moon is also traveling with us. So we have that bulge moving at a slower rate than us, and then we catch up, and then it goes back a little bit slower. So it's weird because we're taught that the it's actually pulling the water closer to land, and then it's pushing the water away from the land. It's actually not how it works if you look at the larger scale of it. But yeah, the polar shift is gonna happen. It's not a matter of if, it's gonna be when. Like,
Yeah.
and it's a naturally occurring phenomenon. Life has survived Earth apparently when it happens. I mean, we are more reliant on like the minute details. Like I doubt the early creatures cared about the pole shifting. Like for us, we will probably affect us a lot more than it did the other stuff. It'll probably like affect our power grid and how things are, how power is created. But
Could potentially affect migration patterns.
yeah, it could affect how, I don't know if how it'll affect weather. I'm not an expert to know if it'll have effects on weather, but if birds use magnetic sensors to tell which way to travel, this could definitely screw with
Yeah.
them.
Or even like the monarchs or insects that migrate.
Mm-hmm.
Yeah. So here's a question though, right? So humans are inherently flawed or inherently corrupt, essentially. So if there was generational space travel on a ship that had everything you needed, discarded bodies would be probably, or after you die your body would probably get jettisoned into either the vacuum of space or at some point maybe even used as a compost material to just continue whatever they may need on this ship. Generationally, think about it. Do you think that people would be able to have the mental intellect capacity and emotional control to be subjugated to living in such a confined space over generations? So when you're born, your parents tell you this is your purpose, you're to have kids to continue the next generation. You will never leave this ship other than, for occasional spacewalk, whatever repair, but you will never know what it's like to step foot on a planet or to breathe air without having a suit on or filtered air. Do you think at some point they would be able to continue, let's say multi-generational, to get to another galaxy, or would there be some type of corruption and mutiny that would occur and it would just be the end of it?
I'm sure it would happen on some, not all of them. So say that they sent out 10 ships with this mission of doing just repopulating, creating more people to work in the ship, and then next generation does the same thing. Out of those 10 ships, maybe 3 of them will have a mutiny of some sort. But I think that the key distinction between that happening on Earth versus that happening on space is you leave that ship or something goes wrong, everybody dies.
I think
Anything out there wants to kill you. There's just the natural forces on outside of that ship want you dead. So that would create, I feel like, a bond between everybody that's on the ship. Of course, you're going to have people that are mutinous by nature or have some kind of defect where they are, they could be greedy, they want the power, or they might be, suicidal and say, I don't really care what happens to everybody on the ship. And that's a possibility, but
I think machines would be a better option. As much as I don't like the idea of an actual human being raised by a machine, I think that having a machine, having fetuses, embryos transported a very large amount, right? And then when they get to their destination, the machine raises the first couple and then they take over. Now, that still falls into Tim's thing. They could just be like, haha, fuck those kids and leave. But I think that's, I think limiting the mutiny aspect of it, or putting generations in a quote unquote suffering aspect, is a better choice.
or you would design it in a way where the first generation would not let the second generation know about Earth or any of the things that are happening.
Or you would design it where the first generation is born, raised, whatever in space, just explicitly to get it started, and then when they land, you got a few people that can go. The rest will probably die from gravity, but whatever.
Yeah, the journey itself is what is hard to survive, because there's only so long that humans can survive on space, because we were designed in a gravitational environment.
And that's the other thing too. We're talking about a lot of steps ahead of what the fuck would actually happen. First thing you gotta do is identify a planet that you can even go to. Second thing is you gotta send probes to it to make sure they actually can live there. And you gotta pray that all of those work out, because if a probe dies or whatever, you gotta send another one. I mean, and then there's this really cool movie, Alien Planet. Have you guys ever seen that?
I might have.
Oh man, dude, it's killer. So they send 3 probes out to this alien planet, and they're like super smart, right? Took them like some crazy amount of years, like 107 years or some shit. They finally get to the planet. They release all the probes. They land, and one of the probes immediately dies. And what happens is the probes are designed with AI that is kind of like an infant. So like they're programmed to learn, but they're programmed to learn different things. All 3 of them had different like
mission sets.
Yeah, core missions. And the one that died, now you've just lost that core mission. Now they said that, Earth like responded back. It takes like 2 years for it to get back to Earth and then back to them or whatever. But they responded. They were like, "Oh, they just made the other 2 do its mission," but you're not getting the full. Yeah, Alien Planet, bro. I'll look it up.
Imagine if what if one of the probes' mission was to tell you if there was enough oxygen to survive, and that's the one that died. The other 2 does not matter if you don't know if there's enough oxygen on the planet to survive. Right. So like it definitely makes a difference.
If they knew for certain that all of the let's say there's a planet out there, it takes 200 years to get there. we have the capacity, and let's say a generation lasts 20 years, so you're going to have 10 generations from the time you leave Earth to the time you get to this new planet. I mean, the ship will have to be big enough to account for genetic mutations, so you don't have ancestral relations happening that continue these generations. So there's going to be enough people on this ship to prevent that. But I think at some point it would have to be almost established, right? So you have a captain of the ship, right? And then you're going to have to already predetermine so and so is going to be the captain. There's going to have to be some hierarchy structure on that ship to make sure that everybody's doing the necessary tasks that they need to, almost into a militaristic way, but still allowing people to be people, so we don't lose that trait once we are able to inhabit another planet.
Yeah, see, that's going to be, I don't think in any scenario of that, people would be the same by the time they reach their destination.
Oh yeah.
It would be a different thing altogether, because you'd be dealing with people that have only known space.
Okay.
And they've only known the people with them.
I guess even a little closer to home. This is listening to a different podcast, and one aspect that they were talking about was, let's say we go, and I have not seen that movie.
It's good, dude. So like, this is the probe right here. So they float and they fly and they got little faces. Oh. And they like have all these different creatures that they talk about, and there's actually like intelligent life. This guy, it like tries to communicate to him. It's a pretty good movie, man. Highly recommend.
Alien Planet. Okay. Yes.
So I guess, like, let's say we go and colonize Mars, right? These guys were talking about, all right, so here's an interesting thing to think about, right? Religion on another planet. Some religions are more, I guess, Earth oriented, or specifically like Muslim religion. When you pray to Mecca, you, depending on where you are at globally, depends on the direction that you're praying to. He goes, depending on where the Earth is in location compared to Mars, it would change. He goes, sometimes you would be praying straight up to the sky, and other times you would be praying straight down, through the planet. So he was theorizing, he goes, it is potential that as generations progress on a colonized planet, that their own forms of religion can occur.
Yeah, I mean, you get a group of people together isolated from the
Dead
rest
space,
of society. Man. You get Scientology, and that's definitely an interesting example, because here's the thing: would religion even exist in that kind of environment?
That's another thing, because so this guy that was, I can't remember what his name was, but he's a geneticist who works for NASA, right? There are some genes that correlate somewhat with religion, but then the aspect of actually practicing religion is more of a societal thing, or like it's a instructed or a taught thing, because there are some relations genetically, but it's not, of course, the whole picture with it.
Yeah, I think the gene that he's talking about, they've done some studies on it. It's the gene that pretty much makes us want to be part of something like a group. It's the group mentality, like where you want to be accepted in a group. If that group is, a religious group, then that's that, because that could be based on where you grew up. It could be a group that's anarchist, if that's what you grew up around. But it's the sense of belonging that I think most humans have, where they want to be accepted and part of that group. And I mean, that's a survival gene for us, right? Like early humans needed that gene to survive, because it helped us be more team players and be more part of a society where we could have a better chance of surviving and spreading our genetics. So you get up there and you go to Mars, you can pray to whoever you want, but then generations that follow, there's less. I doubt the first thing you're going to do when you get to Mars is build a church or build a mosque, right? So think about it. It would
Yeah.
probably take us hundreds of years to build just the basic infrastructure. By that time, people have gotten used to not going to church, not doing all these things. They have all this other time that they're spending doing other things. Religion could just become something that is an earther thing versus a Mars guy, right?
Yeah.
So you have an Earth guy. Oh, these guys are religious fanatics, and then you get Martians. Oh, we're sensible people. We don't worry about any of that stuff. So, and my
But
biggest worry when we get to that kind of society is where we have multiple planets. I mean, we're pretty good at killing each other.
yeah,
At what point do they become independent? Like, oh, we're a colony, but we'd like to have independence and autonomy. And
so
then
I think
Earth is like, no.
even one of the interesting things about that though is that colonizing and living generationally on another planet, you cannot escape the history of Earth, because what led them getting to that planet was everything that had occurred here. So I think, we could put every book on some type of electronic file, every single music song, everything that was ever listed. They would have access to an extremely large data pool to start a completely new life on another planet. So I think at some point, I think there are some things that would remain very similar, but there are other things that would definitely change. I mean, even psychologically, like Mars, I think about, all right, they know that there's potentially lava tunnels that they could use to inhabit, build their colonies underground, because it would be safer to protect against radiation, temperature extremes. Everything would be a little bit more controlled in an underground environment. There'd be definitely physiological changes as well as biological. This geneticist was also saying when he was studying Mark Kelly that the differences in genes that would lay dormant that we don't use here on Earth, but then can become activated when you're in space for a long time. Or I can't remember the name of the cell, but as you get older, these cells typically shrink. But in space, they've found that the cells actually grow longer, which would be more attributed to a youthful cell than an aging one.
Yeah, we just don't know, which is part of the reason I feel like
Yeah.
space travel is important. It's almost, I hate to say human experimentation, but each person that goes out into space, we learn more and more about the medical implications of being out in space, right? So the biggest threat to us in space is our own physiology. Like when you get exposed to the vacuum of space, you're basically just the air inside of you is trying to escape, and literally your blood is just boiling because all the air is escaping out of you. And it's like, I can't think of a worse way to die. Like, so you're in space, so you're in an environment that completely wants you dead. No matter what planet you go to, unless you find a planet with an atmosphere that protects you from the vacuum of space, you are always going to live in some sort of bubble. That's just the fact. That's how it's going to be. So either the human civilization, as it reaches further and further into space, becomes an evolved version that's separate from what we are on Earth, or we would have to permanently live inside of a bubble where we can only survive if we're in that bubble.
Which was interesting too, because even on the space station, he was talking about they have these compartments, everything floats up there, so liquids get out, food particles get out. He goes, it's been documented there are new types of bacteria, right? Not all bacteria is bad. I mean, our bodies are full of bacteria. There's bacteria that lives on our skin consistently. And so we're just full of and completely surrounded by microorganisms that coexist with us. And they found that those same things are existing in space, so that astronauts who go up to the space station, their T cells are actually starting to really procreate, so they can take log of all these new bacteria, so they can, so your body can try and prevent yourself from getting ill. I just thought it was kind of an interesting thing that new bacteria are even being discovered on Earth. Apparently there's this swamp or whatever, an absolute wasteland of a water source in New York that is so harmful because it was a chemical dump for like, I think it started around the 1700s. So anything and everything was just kind of dumped into this pit. They've found bacteria and stuff that essentially thrives off of that and is almost in a sense somewhat cleaning it, but it's completely toxic, of course, for a human to even touch.
I mean,
It's
there's
kinda
stuff in,
interesting.
yeah, there's stuff surviving in what we're learning more and more is that bacteria, like we think of bacteria as just germs and stuff that can kill us, but these are organisms that will most likely outlive us. If something
Yeah.
cataclysmic happens on Earth, we will not survive, but bacteria still will, because it's basically there's so many different types of them. There's ones that can live in radiation. There's ones that can live in the bottom of the ocean under all that pressure feeding off of sulfur. Like there's even theories that early microorganisms that eventually led to mammals, like a lot of that came from asteroids hitting Earth, coming from all corners of space. So I mean, I'm not saying that this is true, it's just one of the theories that are out there regarding the origin of life on this planet, because they wanted to kind of take a look at, you know, how could all of a sudden you have this giant soup of materials in the water and something gets introduced that all of a sudden kickstarts the genesis of life on this planet. But and also when we're traveling to these distant places, if we land on a planet, we can't just take our helmets off and breathe and feel like everything's going to be okay, because you don't know what's living out there. If the microorganisms that our bodies are used to here are enough to kill us, imagine being introduced to something that's in a different distant planet that is completely new to our biology. And that's why, like, I think a lot of people, especially some of the people that I've talked to, like, why are we spending botanists into space? Like, what's the point? Like, there's a reason. NASA is not dumb. They're not sending a botanist out there so he can grow a bush in space. They're looking at how can we farm in space? Like,
Yeah.
how can we produce food? If you're going to send a colony to another planet and it's going to take 60 years to get there, they're going to need food. They're going to need not just packaged food,
Yep.
but an ability to grow, you know, all these vegetables and things that they need to in space. And if our biology is different in space, guess what? Plant biology is also affected in space. So it's kind of something that we have to be wary of when we're doing this kind of voyage into something unknown.
Which I learned about sending things up into space too. So let's say you want to send a robot to space, right, to assist on the space station, whatever it may be. So you have your initial robot that's actually going to go to space. You have a robot that you have to set on fire here on Earth because they need to know how it burns. And then you have to have a robot that you can just destroy with like a hammer because they need to know how it breaks. So in the case of any of those things occurring, they know how to appropriately respond to it. So, you know, you're setting up a $3 million robot. All right, you have to have the $3 million one that you're going to light on fire, and you have to have another $3 million one that you're going to hit with a sledgehammer.
These can't be mock-ups. They have to be the real thing.
Yeah, they have to be the real thing. And when it comes to using liquid in scientific research, he said that they do have like this kind of regulated capsule that they can do tests with more hazardous liquids, because you still want to know what happens. But there's a whole series. All right, what is this liquid? If it gets out, how does it interact with space? Because, you know, everything just kind of floats around. What if it gets in an astronaut's eyes? What if they breathe it in? You know, so there's all these like checklists that they have to go through for safety measures. And, you know, like, of course you want them to be safe.
In space, because the lead can break off and cause all kinds of problems. It's like the things that you don't think about. It's just like, we only use pen in space. Like, why is that? Why not just use a pencil? Well, because the lead, even though it's small, it can get into people's eyes because it's floating free floating. It's not falling to the
Yep.
ground. It can puncture things that we might not expect it to. Like, this costs money. You're constantly experimenting in space to see what could go wrong. Because I mean, you think about, was it Apollo 13 that had the issues?
Yeah.
And everything went wrong.
Yep.
Everything went wrong. Anything that could possibly have gone wrong went wrong in that system, by to the point where they were basically manually guiding this thing to re-entry.
Yeah.
And they are on a razor thin. And guess what? The training, the amount of money, the time, the things that they put into, that's the reason those astronauts survived. They were doing mathematical calculations on space to show this person which way he'd have to go. There's no computer assist, nothing. And they were basically just using human intellect, what we know about what happens when you do this and that, and basically just created a scenario where we were able to bring these people back home. That blows my mind. Like I said, we sometimes don't give human ingenuity enough credit, but like when you have scenarios like that happen where the world is watching, like it was so very easy for something to get messed up in that process. They were literally jerry rigging things. They had a display version of what was out in space, and they were basically going in and be like, okay, how can we jerry rig to make this work?
Yeah.
And they would call back and be like, hey, this nut is not going to work on this hose, so you're going to have to go grab a piece of that thing over there, cut it off, put it on this hose, then clamp it to where it needs to go, and then it'll work. And they're like,
Yep.
okay. And they just did stuff. Like, it's jerry rigging in space while like just descending to Earth.
Yeah.
Speaking of like colonization and stuff, have you guys seen anything on either Man After Man or All Tomorrows?
Mm-mm.
I don't think so.
Explain.
No, we're gonna have to do a whole episode on just those two things. But
Colonization.
no, so it's a theory that you have humans that did end up going intraplanetary, whatever.
Mm-hmm.
And like it was funny because you were talking about planets fighting. So Earth and Mars, because the Martians evolves like into different humans,
Mm-hmm.
they actually get into a war. And after this war, another intelligent alien species called the Q come down.
No
and,
relation to QAnon.
No, and they end up actually like genetically modifying humans and making them like these perfect workhorses for the things that they needed them to be. So whether it be food, whether it be waste cleanup, whatever. So it's a really interesting take on like what humans could look like. And then the Q actually leave after a couple million years, and it shows you more about the humans like becoming what they were. It's just insane. Well, I'll have to send you guys some videos. And
Yeah, I'd like to
we'll do a
watch
whole-
that, because
It's crazy, bro.
that's also something that I wanted to talk about in terms of like it. So we have an endless universe where we have all these, so far we found, I think it was close to 10,000 planets that are habitable based on our analysis of what the minerals and found the makeup of the atmosphere is in those planets. So out of those planets, we are now, we don't know how many intelligent life forms there are out there, and we don't know what stage of evolution those life forms are. But should we be risking sending our information out into space?
That's a good question.
Like we are actively, I think one of the first messages that we sent out there was like the coordinates of our planet in the solar system based on our how we describe it, sent out into space, along with excerpts of our culture, what we look like. I think recently NASA just sent out like nude humans in like docs form.
Yeah.
Like if you look at the picture, it just looks like somebody drew a picture on DOS and just sent it out into space of like our anatomy. It's a crude drawing, but they just sent it out into space and they said, here it is, a picture of what our DNA looks like, and just sent it out into space. And I'm just like, I understand the concept of what they're trying to do, but is that a smart thing? And now I'm not saying that we're going to get invaded by aliens. I'm not a tinfoil hat kind of person, but like just for argument's sake, should we be doing that?
So, but here's another theory. What if we are the most advanced civilization in space?
That's
What
definitely
if-
a possibility.
because space, relatively or evolutionary speaking, is still extremely young. We had, looking at the evolution or Big Bang Theory portion of it, we had so many years to get to where we are that other planets or solar systems may still be in that infantile soup of just a variety of chemicals and biology going on. And they may not even be able to communicate because they're still single cell organisms who haven't met that evolutionary point to where they can do space travel, to where they even have a thought process.
What if they already know that we're here and they're just blocking our signals?
I think that would be a very real possibility, because if I was looking from the outside in, I would probably block us too. It's like flicking through the TV when you're watching stuff and you come across this and you're like, oh, it looks kind of interesting. You watch it for a second and you realize you've made a horrible mistake.
Yeah,
So
you're
you
like,
change the
"Whoa."
channel. Yeah. I feel like that's what Earth would be to
we're the
other.
Jersey Shore of intergalactic planets.
Yes.
Just the
We're a
absolute
TV
garbage.
show like in South Park.
Yeah.
They're
or,
like, oh god.
Or in Rick and Morty, how they have like the intergalactic TV station, and then like, and here's Earth, and Earth is just kind of like the laughing stock of the universe because
Yes.
things are so screwed up.
Everything, like even everything that we do as a planet is so messed up. Like, we're just to if there was a more advanced civilization that could observe us in real time, we would be so primitive to them that we would not even be worthy of studying.
Yeah. So even like, so if there were aliens, right? Aliens came down, helped build the pyramids, whatever, get ancient civilizations up on their feet, gave them technology, just like theorizing here, right? What if they realized that humans only have a certain intellectual capacity? So they're like, you know what, we're done here. They're never going to be able to be on our level.
And just left.
Yeah.
Well,
And then just left.
One of the theories I really like is that it's the Star Trek theory. So there actually is like a united planets, right, for the universe or the galaxy or whatever.
And we're just the planet that they won't interfere with.
For right now.
Like, let's see
yeah.
how this plays out.
And so the rule in Star Trek is you can't interact with a planet until they discover warp drive, right?
Yep.
And so there's a movie actually where Picard and them go back in time to save the guy that invented warp drive in like 2200 or whatever, because the Borg or something was going back to kill him, and they save him. And then when he hits warp drive, all of a sudden, like all these UAE or whatever they are, spaceships just show up, and then that's when you're able to get in, and you can choose not to join, obviously, but like I think that I honestly think that might be the most realistic thing. It's kind of a mix of Tim's idea too. Is they're not there yet. We just need to wait. They'll get there.
So let me put this scenario out to you. So the planet exists exactly how it is currently. It's the year 2200. We've just invented warp drive. A group of 6 spaceships appear out of nowhere. What are the chances we don't just press the nuclear button?
I'm sure every country in the world has
a first contact.
There's a first contact law. You can't
Is there?
Oh yeah. There's no way every civilized country.
Yeah.
Let's say that they have been watching us. They know what countries they should be going to. USA, Russia, European countries, right?
Yeah.
Like no, not a diss on Africa or anything, but like they're not as advanced.
Does Africa
as these
even
other
have
ones.
nuclear weapons?
I don't know. That's not what I'm getting at, man. So like Australia, right? Like they know where to go. It's not this. It's not going to be like they just appear and they're like, oh, bibbidi boppity, we're aliens, and then they get just lit up with AK fire.
How do they know? just Somalian pirates. Look at me.
I am the captain now.
I am captain now. So like, so they show up, and then like what? So there've been observers on the planet just waiting for a warp drive,
Not on, just around.
and they're just like warp
Because
signature.
in Star Trek there is a signature after you warp drive,
Yeah.
and these ships can detect that. So it's not like they're just hanging out in our atmosphere or anything. They just know that we're there, and then they can just monitor for a warp drive signature. Once it's there, they have diplomats and stuff that are ready for situations like that immediately go to those planets. That's what would happen. And I really do think that that's actually probably what's going on. I think that we're not the most advanced. I think we're the least advanced. And I think that they're just waiting for us to hit a point, whatever this unification goal, hell, maybe even just becoming unified as a planet. They're like, hey man, they just passed this law.
Yeah, but we're going off of human logic, and we're putting that towards alien species that.
Yeah, but
have
diplomacy is kind of the same no matter what culture. I know it's human logic, but I mean, there's diplomacy even in the animal kingdom in very like animalistic terms, right? Like an elephant knows not to go into another bull elephant's territory. Even if he does, he's probably knows that he's going to get into a fight if the other one finds him.
Yeah.
So it's the same kind of concept. If it was a species that just wanted to kick our ass, they would have just done it.
They would have hit us in like,
yeah,
like 500 years ago, like
just
absolutely eradicated us.
So.
Now, okay, so as first contact happens, who would you want there?
So
who you want there? Who's the first guy? Who's shaking that alien hand?
Is this a positive or a negative interaction?
You choose.
So if it was a negative interaction, I'd definitely send Nancy Pelosi.
She's like, you look just like us.
If it's a negative interaction, I'd send anybody from any kind of political spectrum.
I want Duck Dynasty there.
If you want a positive interaction, it's gonna have to be scientists and stuff. I mean,
I think it would have to be like, who would you want to be the ambassador?
So interesting topic. Star Citizen, right? I've been listening to some of its lore. Star Citizen, for the viewers, is a computer game that's in pre-alpha right now. It's interesting, but it has its
forever
own lore.
alpha, guys.
Yeah. So, in the lore, what happens is they become united, right? The Earth, and then they colonize other planets, and then what happens is they have like this really long turmoil of like basically having an emperor, an imperator, and they finally are like, all right, like it's not the guy. So what they decide is that they're going to vote in a human, like just a normal dude. I can't remember what they called it. It's just an everyday Joe. Somebody who, if a split decision has to be made, right? Like it's their call. They're not in politics. They can't really be corrupted, but they're supposed to speak for the entire Earth and all people of the United Earth emissaries. And so I think that would kind of be like what we would have to do.
So it'd need to be someone of good character, ethically and morally, you know, so definitely not the Pope.
Can't be the Pope. No religious figures. No religious figures. It would have to be somebody that is.
I think Neil deGrasse Tyson would be a good choice.
Yeah, but he's a little bit arrogant, though.
Yeah,
he's a little full of himself sometimes. That's the thing. Like,
I think we should send the guy that does like the aliens.
He's like, he'd be so psyched, dude. Honestly, I feel like he'd be like, so happy that he would just be like, yes.
Yeah.
Validation. We can't send Alex Jones because he'll just start talking to them about nonsense.
No.
Yeah. It would have to be somebody. There's another. The Asian gentleman. He's actually pretty cool. I forget his name. He's also an astrophysicist.
Who's the one astronaut that was like also a Navy SEAL and then became a medical doctor and then was a astronaut?
Oh, yes. He's the trifecta, the one that brown parents always compare you to. Yes.
Yeah. I feel like he would be like he's a badass for one, right?
Mhm.
He's extremely smart, both medically and scientifically beyond medical science.
Mhm.
I feel like he would be a
Well,
really good candidate.
he's an astronaut for his medical background, though. That's the thing.
Yeah.
He's not
Well,
a
they
background for astrophysics or anything like that. He's a medical doctor because they need medical doctors up there
yeah,
too.
but he still has to have acknowledgments of space and engineering in order to even go to the space station or do
Mhm.
space flights. So I'd consider like anybody that's an astronaut has training and knowledge
I mean, that's
through
assuming that we
like
have to
those
meet them in
studies.
space. Like, if they come to Earth, then
Yeah.
And how would you decipher language?
I'm gonna assume that they have language translators.
Morgan Freeman.
Oh, that buttery smooth sound.
Do you
Those
imagine
aliens would be.
he's the
That's a
first voice you
great
hear?
ambassador, dude. Morgan Freeman, save that man. Keep him frozen.
Or Robin Williams if he was still alive.
Oh, Robin Williams would just start cracking jokes, and the aliens would have no idea what's
Yeah.
happening. Like, the dude's name is Michio Kaku. Is the astrophysicist? He's a theoretical physicist, and he's actually pretty awesome guy to listen to. So we're dropping some names in this podcast, guys. Please go online, check them out. There's a lot of extremely smart individuals, much more involved in this field than we are, and have so much more information. Brian Greene is another one that I would recommend. He's a theoretical physicist. These guys are the people that are sitting in a room somewhere doing math equations for fun.
Yep.
Like, these are the guys there, like the guys that are on the razor's edge of mathematics. It's these guys. So of course I did say Neil deGrasse Tyson was a bit pompous. I mean, that's just our interpretation of him. He's still an excellent educator. You'll still learn a whole lot listening to him. So
All right. Earlier the geneticist that I was talking about is Chris Mason. He is a professor of genomics. I can't even talk. Physiology and biophysics. He teaches at Cornell.
Genomics?
Yes.
genomics.
Words are tough.
Genomics.
Yeah, he was the main person that, or one of the main people that asked NASA to attempt to do a twins study for long-term space. Yeah,
oh,
so
that guy's going all angel of death, huh?
yeah,
Twin
so
studies.
he said he was like, hey, you guys don't even have to pay me. I already have the funding for this. We want to do this. And they looked at him like he was crazy and told him no.
Your children.
Yeah,
Yeah,
and then years down the road, NASA was like, hey, we might have some candidates for that study that you wanted to do, that you asked us about years ago.
Mm-hmm.
But he primarily does research on long-term effects of space on the human body. He's also the author of The Next 500 Years, Engineering Life to Reach New Worlds. It's actually a very interesting listening to him speak about these kind of same topics.
Yeah, I mean, so we have to understand, we are at a certain point when we get to these like more complex questions, we are at the boundaries of what we can explain with what we have, right? So we look at something like dark matter and we're just like, actually, I think a lot of scientists hate that it's called dark matter because it makes us think that it has mass and that it has something that we can like grab and hold. It could
Dark
just
matter
be
matters.
Yes, dark matter matters. God, the dad jokes never end. I apologize for our resident ginger here. He can't stop. He's had this problem since childhood. Ever since they told him he could be a dinosaur, he's decided I'm just going to be a dad.
Exactly.
That's been his calling in life. So yeah, so dark matter is something that we know nothing about. We know that we can measure the gravitational force that it exudes. I think for a long time people thought, did you guys ever heard of the Nemesis Theory? So it's a theory that outside of the belt of the asteroid belt in our solar system, there was another planet out there whose gravity was forcing these asteroids to come and hit the Earth. Because like they thought that, the periodic extermination of life on Earth, they thought that it could be something out there, and they called it the Nemesis, which is a cool last name, by the way. You call a planet the Nemesis, but after they did some research, they decided it wasn't possible for something to be out there. Like, we would have noticed it, and if you have that out there and all these asteroids hanging around, we'd be hearing more frequent meteors coming towards us. But like, it's stuff like that where we have no idea. The asteroid that came into our solar system that everyone thought was a spaceship. Do you remember hearing about that? Yeah. Everyone thought, I think there was a German astrophysicist that was all in it. He's like, yeah, there's something about this that isn't normal. We still don't have any real way to say yes or no, because we know that it wasn't a spacecraft, it was just a rock. But what was unnatural about it was the way it traveled, almost like somebody had flung it here, not that it had followed a normal course. So
It probably did.
And that's, like I said, it could be an unknown force out there that's pushing and pulling things that we don't have an understanding of. So
I was watching a universe iceberg theory. So we're under the impression that the universe is like ever expanding, right? But the theory is that everything that's within the universe is kind of just moving as a wave, right? There's controversial theories right now that are pointing towards the possibility that there might be something that everything is gravitating to past the observable universe. That's frightening, bro.
So instead of the push of the Big Bang, they're thinking it's the pull of something else that's causing the ever-expanding acceleration?
No. What they're saying is all the galaxies and everything that are in there that have been moving as like a wave, kind of. Instead of it being a wave, there's some math, it's controversial, that might be pointing towards the fact that these are actually moving towards something that is outside of the boundary of our observable universe. That's scary.
Yeah, I mean, but that's the thing, though. The boundary of the observable universe keeps getting larger and larger, right?
Yeah, but what would be past it that would be pulling things?
Nothing that we could ever see or ever measure.
What could it be, though?
A bigger, badder black hole? Could be something else. Like, there's no way to tell.
We're in a black hole right now.
I mean, there's theories that the other side of the black hole is another parallel universe exactly like this one.
I like the Futurama episode where they go to the edge of the universe and they look over and it's them in cowboy hats. They just wave at each other. That's my favorite.
The edge of the universe is just the reflection.
Yep.
The universe is flat, bro.
So what do you think, like, if the movie Interstellar would have been, or could have been, a real life matter, where he was kind of in this suspended space, I guess you could call it, but he was like signaling like with the books to his daughter that was in the room or something by pushing the books.
Well, he was in the fourth dimension, right?
Yeah. So they said that was actually surprisingly very accurate, because for us three-dimensional beings, two-dimension exists right in front of us and we can affect it any way we want, right? We have full control over two-dimensional space. Versus if a fourth dimensional being looked at a three-dimensional being, they'd have the similar way. They could look at all things happening at the same time and affect things. But
that's what's scary, is he was the fourth dimensional being.
Yes. Yeah. So the most unbelievable portion of that is that he went through the singularity of a black hole and survived, which is almost an impossibility, because you actually get crushed. No, you turn into a spaghetti. The spaghetti. So what happens is it doesn't actually rip you. It's spaghettified. So if you go in foot first, your legs will just get elongated and elongated. The gravity literally turns into a string of spaghetti, then segments you, and then those segments will get elongated and then segment again, and then you'll just endlessly get torn apart. You'd be
one atom long by the time you get to the singularity.
Pretty much, yeah. By the time you get there, because I mean, they tried to kind of show it with the ship warping and turning into this, but if the ship warps, the things inside of it also warp. So there's just no feasible way to survive a singularity event, to even see, you can't even send a robot over to see what's on the other side. It just wouldn't survive. and we don't have anything that can hold that much gravity at bay, so that way we can
It'd
actually
be interesting
cross
to
it.
see, though.
Well, it'd be interesting to get close enough just to see the recording, and like, when does it stop recording? When does it get absolutely shredded apart?
Yeah,
Right?
and the scary thing is how time would go slower for it, so it would actually be like 100 years.
Oh yeah, that blew my mind. The fact that that
Yeah.
one planet was next to a black hole,
That shit
and the
blew my
gravitational
mind.
force. They left for like, I think it was 14 minutes, and they came back. 7 years had gone by. Just the difference of time between being on the planet versus,
Yep.
Yeah.
like, it's just hard for us to conceptualize that, because we're like, we can understand, oh, you take a flip piece of paper together and put a hole through, and that's a wormhole. Yeah, it's a simplified explanation of what's happening, but like, to be on a planet and have a buddy in space circling that planet, but have a disparity of 6 years and some hours between the person, what they experienced on the ship versus what they experienced on the land. Like,
Aging and how we do age would change depending on what planet you're on,
Yep.
yeah,
because even physiologically and biologically, your bodies would not be the same as it was on Earth.
mm-hmm.
You know, let's say you were third or fourth generation person, you know, living on another planet. Your body's at some point is going to be already acclimated to whatever conditions you're living in, but you will age differently, and
Yeah.
that's without a doubt. Even in the short-term studies that they've been able to do from the space station, your body ages, it changes.
I mean, even if you could go say you could travel the light speed, and you have an object that's 1 light year away, and you travel to it and come back, the family members and you, like, the age difference will be closer together,
Yeah,
because you've technically experienced less time than they have because of the speed in which you were traveling. So like, each time you do that,
they're going to age
they're
more
going to
than
age
you are.
more than you are. So you will eventually catch up to the point where each time you do that, you might come back one day and you're the same age as your parents.
Yeah.
Or I'm sorry, your kids are the same age as you, right? So, which is what happened in the Stellar. Yep. Like, they came back and all of a sudden, like, his kid's like
95.
40.
Yeah.
Yeah.
And that's the crazy part of the relativity of time, because it's just we think of time is absolute, that it will go from one past to the present to the future, but the rate of that change is what's relative based on where you are and how it's going. And it's not just speed, it's gravity will affect that too.
Yeah.
So for that planet, was it spinning faster? What was, I forget. I want to watch that show again. I want to watch that movie.
It was just the fact that it was in the event horizon. The event horizon was affecting time, or perceived time.
Perceived time.
Because that's all it is. Time is just the perception.
Oh my god! And then being next to that giant black hole, the wall of water, basically a super tide that was just washing over the planet one after the other. So, and the idea that even though it had been 10 years for them, that person technically just landed like 7 minutes before them.
Yep, that's scary.
That's the scary part.
Like his body was just fine. Like it was just floating there. Remember?
Yeah, and you could find his ship, and it was just fine. It was just, even though it's been 10 years since that guy landed there for Earth, he's been there just 7 minutes before them. And, you know, that's the crazy part.
So speaking of time, right? So you were talking about how that theory that time was relative because he was driving away on a bus and it looked like the clock hands were moving slower.
Yeah.
So a good way to explain it is the horse and train theory, right? So if there's a train going 100 miles per hour, the faster the horse runs, the less the train seems to move, right?
Okay.
Because if the horse was running at 100 miles per hour and the train is moving at 100 miles per hour, the train to the horse doesn't look like it's moving.
Okay.
If there was nothing around you, like no desert, nothing, it was just the train and the horse, it would look like you're going the same speed.
Yeah.
But if you're going slower than it, the train looks like it's getting away from you. With light, this was really interesting. If that horse, if you could see light as a physical thing, and that horse was running at the speed of light,
Mm-hmm.
light would still look like it was getting away from you.
Even if the horse was traveling at the speed of light.
Yes. That's crazy. The horse would, even if the horse was traveling at the speed of light, the speed of light as a physical entity would continue to look like it was ahead of you, no matter what. That's crazy. That, I mean, my brain, dude, I was done
That's
after
even
that.
hard to comprehend because you think that both of them are equal in speed, so they would be traveling side by side. But there must be some property in which how light affects space.
It's probably a
right?
distortion effect.
Yeah, because I mean, we think about space as like just all around, right? So it's basically just, but it's more representative to like a fabric, like a cloth. If you ever put a basketball on a towel that's let out, and you watch, and you can move that space, you can watch the basketball spin and roll. That's basically what's happening in space time.
Yep.
So as that bends, like just the idea that light
I know. My brain, dude.
and it with as powerful and as like almost like mythical the force as light is, like there's gravity, it still bows to gravity.
Here's another crazy thing about light. So they had the you know, that experiment where the guy poked a hole in a dark room and was looking at light hitting the wall, and that's how he figured out the speed or whatever, I don't remember. So they did a similar test, right? Dark room, they filtered light through it, and they had the counter, the photon counter. So they let the light go through one slit, and it hit the back wall, and the particles reacted the way they thought it would. They just kind of went and bounced. Then they put a wall in front of the slit with two openings on either side of it, and then the back wall with a photon counter, and the light acted like waves.
Yes, I know this experiment because the experiment was trying to show, because the theory for the longest time was light moved in straight lines. And then I think it was Einstein that theorized that it actually moves in both straight and in waves.
Yes.
Which is a trippy concept to understand, because you think of straight as it's just going straight, but apparently it's superposed where it's moving at the same time. It can be moving in a line and in waves, because that's what they're trying to do. Because like when you look at light, so when they first realized that the visible spectrum is made up of white light, and white light turns into Roy G. Biv, right?
Yep.
It's the different wavelengths that make up light that give us all the different colors, right?
Yep.
So in our mind, we'd think, okay, so light moves in waves, but according to the math and according to experimentation, light at the same time also moves in straight lines, which is so hard to understand. Like,
did you know 1 billion years before the edge of the universe, like if you could travel super fast right now, 1 billion years before you would hit the edge, the universe would actually be red, because it's no longer microwaves, it's actually in the red wave spectrum.
Is that infrared?
No, it's past infrared. We're in like the microwave section right now, right? You'd get into the infrared section, and then you'd go past that to the visible light spectrum, and you'd actually get to red. The universe is red from 1 billion years from the edge to the edge. That's crazy. Like, dude.
Well, the edge that we see there is technically the closest we can get to what the universe would have looked like at the Big Bang, right?
Yes.
Yes, because the edge is what the universe would have looked like, because there is an idea, because redwood, it would make sense because the universe was super hot. When the initial Big Bang happened, everything was super hot, and it was just exploding and just going at insane speeds.
Oh yeah, it was. Sounds like my sex life. Super hot at insane speeds. There it was.
Yeah, there's the clip. It sounds like my sex life. Yeah, so everything, and apparently, did you know that the temperature in the universe is slowly going down?
Yes.
So because I think they can tell because of the microwave radiation, but like eventually it gets to the point where there's not enough force to actually hold like atoms together,
Mhm.
where protons, everything will start disintegrating. And it's called what is it called?
Probably this universal decay theory or
It's
something.
heat death.
There we go.
There
Yep.
it is. It's a universe heat death. So basically it'll get to the point where it's just like nothing can hold together and everything will just evaporate into base particles, and those particles will then get pulled apart.
So will the universe be the shape of a donut at some point then, where it's dead in the middle, dead on the outside, but there's stuff in, you know what I'm saying?
Well, the first, I believe, so it's weird. So you would think that if the outside portion is the hottest because it's the initial energy from the Big Bang going out there, because there was a theory at some point that mathematically it is possible that the universe will just keep expanding forever and it'll never stop expanding. There was an alternate mathematical theory that was posed that didn't get as much steam, where it was actually the universe expanding, then eventually cooling and coming back together to form another Big Bang. So both of those are mathematically possible,
Yeah.
but to what we can tell in the universe, it's just expanding and it'll just never stop expanding until eventually all the heat dissipates and then we go into just heat death. So we have two ways of just burning up. None of us will be alive to understand that. None of us will be able. The human species probably wouldn't be alive to see that because, like,
yeah, I don't even know what might even be alive to witness that. Honestly, that would
dude,
be.
can you imagine witnessing? There should be still human beings on Earth when the two galaxies collide. Just witnessing two galaxies come together, like it's gonna be a light show like nothing else. To go
Also a
into
death
dark
trap.
space. Why?
Well, I mean, shit's gonna start
You'd be
dingling each other, and
You'd be surprised. Apparently, due to the space between everything that's in the galaxies, very few planets and stars will actually collide. So it's almost like it's phasing through each other.
But they're going to come together. That's the problem.
They're going to come together
because the two black holes are merging, is what's happening.
Yes, basically. So I'm sure some other planets will get like just flung off when the tail.
Yeah, that's kind of what I think I was thinking. Is like
Yeah.
different gravitationals. But you'd have time to react to that by that
Yeah,
point.
and I wonder how violent two black holes converging is.
Probably not as violent as we think. It's probably more of like a kiss.
Hey, buddy. Long time no see.
Speaking of, Tim. Tim just showed me this. I don't know if you saw this, Raj. I had not. Pretty sure we can share this.
Is it two universes kissing? No.
Kind of, yeah.
Okay, so for all of our listeners out there, this is from NASA Exoplanets, and it reads that the misconception that there is no sound in space originates because most space is a vacuum, providing no way for sound waves to travel. A galaxy cluster has so much gas that we've picked up actual sound. Here's an amplified and mixed with other data to hear a black hole.
Have you heard this, Raj?
Mm-mm. Yeah, that's War of the Worlds. In real life, when they come to attack you, that's what the sound that makes. It's terrifying and awesome at the same time. Honestly, that's what space is for the most part for me. It's terrifying because it really makes you feel like you aren't shit. Nothing you do is shit. There's nothing that you can do on your life that would be of any meaning to in terms of the vast amount of space.
I
But
have
at the
to
same
stop.
time,
Yeah, I have to stop myself from thinking about it sometimes.
yeah,
I mean,
it's
just
definitely
the vastness, and I'm never gonna see it. And I think that's kind of part of my sadness. Is like, there's no way to just be like, let's go take a tour of the universe. You know,
Yeah.
like, you know, it's there. It'll always be there. It'll be there way after I'm dead. It was here way before I was alive. And you'll just
It's
So-
the
so
missed
much.
experiences. Like I would love to see like you want to be an immortal just to see how everything unfolds, but at the same time you don't want to be because
so
you don't want to
boring.
deal. You'd
Oh
just be
my
bored
God.
of everything that's
I mean,
happening. Like
I've thought of immortality as well, man, and it's like
I think
sometimes
the
I feel
only
like
way.
100 years is enough, man.
Yeah, but I think it's a possibility for immortality, not in the sense of biological life, but it'd be like our interface with AI and machines.
It'd just be boring. It'd be so boring. Like
Just like
the
don't you want to witness the warp
No,
drive?
because the problem is the same shit happens all the time. Like really, when you look at history, dude,
Mhm.
the same things happen over and over again. It's like watching a bad fucking drama. It's the
I just want to
same
be
story.
shut down until something actually important happens.
They boot you up.
Yeah.
Like, ah!
Wait, what year is it? What happened?
Who am I?
What is that movie when they wake up and the world is like just filled with dumb people?
Oh, idiocracy.
Oh yeah.
You just wake up. I mean, that's a possibility, dude.
I think we're headed there a lot faster than we realize.
Yeah, I think that's a legitimate possibility because I feel like stupid just breeds, and that's all they do. It seems
It
they
do,
just
but there will always be smart, I think, as well. And...
That was the most logical, literate sentence I've heard.
stupid will breed, but they will always be smart. Put that on one of your stickers, dude. I want it.
So,
Why say many words when few words work?
work.
Yeah.
But I think what would happen is there'd be like a split, right? So like dum dums can live on one side and smarty pantses can live on the other.
Well, I know what side you're going to, Mike.
Yay!
Yay!
Well-
it do, but smart will always be here. Wow,
So
that's a good clip.
if NASA came to you and they said, "Hey, we're looking at sending you just one way,"
Me dum dum, me go.
would you take it?
How old am I? That's the thing. Have I done everything that I want to do?
Let's say they knock on your door tomorrow
Oh,
because you're say between the age of 25 and 35, right?
mhm.
Healthy male adult, you meet these basic biological criteria that we're looking at to sending one way.
Yeah, but I won't get anywhere. That's the problem.
Yeah, where am I going? Because tomorrow they will still not have the ability to send me anywhere more significant
Yeah,
than maybe Mars.
let's say they did, right? Like you could go anywhere. So let's say we already colonized Mars, right?
Mhm.
And we can make it there in 4 years, right?
Oh,
Along.
maybe.
So we've already colonized Mars, right?
Mhm.
So we're going to send you to Mars.
Am I
Okay.
part of a repopulation effort?
Yeah, I mean,
Are they
eventually
going
would
to pay
be.
me to repopulate Mars?
Yeah,
So-
no, I'm asking, are they paying me to repopulate?
Theoretically, yes. Okay.
Ah,
We'll
yeah,
just say
see,
yes.
that's a yes.
So-
then.
Yes, they're
But
sending
part
you
of
for
that-
snoo,
No,
bro.
so they're sending you to Mars, but your one-way ticket is off of Mars, not back to Earth.
What? Like they're sending you to Mars, but then you have to
There's-
leave Mars one way?
Yeah, they're sending you to Mars to leave Mars to explore.
Oh, but can I still repopulate Mars or help populate Mars?
Well, you're there. I mean,
No, but I'm asking you.
Are they going to give me
This-
like a 3-year hiatus to
Yeah.
repopulate
Yeah, is this part of the
Mars?
conjecture?
so
Will I be snooing 365 for 3 years?
Yeah.
so let's just say that this is like a Navy ship stopping in port in the South Pacific.
Oh,
Things happen, but you're eventually gonna leave.
I'm not pretty enough to do the whole things happen scenario. This has to be a contractual obligation.
there must be partners available on that planet that have already signed the contract.
How about this? I don't get to leave until every single one of the group has been impregnated. Not necessarily by me, but everyone has to have one baby.
Mike's over here like, I'm about to go Genghis Khan on Mars.
He's gonna be the genetic line of Mars will be traced back to a Vandigu.
And then when I leave, there has to be a statue, and it say, "Dumb will be, but smart always
Yeah.
has."
No, it'll just say he came and then he left.
Just he came.
Well, this is definitely getting taken off of YouTube.
There's literally there's like a cylinder full of like a milky liquid, and that's
Oh, God.
that just shows them like, hey, this is the estimation. We don't know. He kept a journal, so
Yeah.
that's what we're going off of.
You're just gonna be like a sperm whale that just dumps the load into the ocean, but you're just dumping your load into
5
space.
ropes with Bessie, 2 with Angela, not pretty.
God. Okay, so here's the okay. You've been allowed to impregnate all of Mars. There you go.
I don't want to just be me because the geneticist in me knows that that's not a good idea. But everyone has to be pregnant before I leave. That's what I'm getting at.
Okay. What if you get there and everyone's already pregnant? Then you've just got shafted.
That will be a violation of my contract. And we'll be having a firm conversation over a year because it's going to take time for those to go back and forth.
He's got to wait for everybody to give birth.
Yeah.
Where's my merchant lawyer?
All right, so I guess maybe so NASA comes to your door, right? So we have the technology to get to Mars, but nobody's been sent there yet. And it'll take 4 to 6 years for you to get there. You're going to stop at the moon first, briefly, to get over to your next ship to go to Mars. Would you take that ticket?
Yeah.
You get to be one of the first to colonize Mars.
You will be the first group of people to step foot on Mars.
Is a group?
So-
okay, you keep messing this up, man. Because if it's a
Yeah.
group,
Well, you're not going
I'm
to be by
still
yourself.
I'm okay. Well, I'm still thinking snoo. So
So you get selected out of a group. So your Brooke doesn't get to come. It's you.
she doesn't
And-
anyways. It's okay.
He's used to that happening.
You are deselected from the breeding program.
Oh no! I'm gonna get in so much trouble.
You just quick cut it out.
All right.
Cut it out. Just
I
cut
love
this
you,
portion.
Brooke.
Yeah, so you were selected to go with this group of people, right? From Earth. You're going to the moon because they already have it established on the moon, and you're going to be that first group of people to be sent to Mars. So Mars already has a base structure put there. They already have stuff going because they sent robotics
Yeah.
and everything like they're planning on doing anyways. But you're just going to be that first human.
Give me
On
like
Mars.
a reasonable amount of people that are actually going, just out of curiosity.
Let's say 50.
That's
a
actually
lot
more than
of people.
that's more than I thought you were going to
Yeah,
say. I would
because
say
you're-
20, 25.
No, so my thing is like sending 50 people is that you have a varied genetic pool because these people are selected specifically, right? Like you may be married here, but your spouse may not be going with you if you decide to take that ticket.
Imagine that divorce.
Yeah,
He's be like,
but-
"Oh, sorry, honey, I got picked up."
But part of this is for scientific
Earth.
research, yeah, and advancement. So your spouse will be taken care of, right? Financially, whatever here.
Right.
So you don't have to worry about anything. But they just need your physical body to go there for whatever they determined from, their selection. So then you're going to have doctors, right? You're going to have scientists. You're going to have engineers.
I mean,
all
out of
these
50
other group
people,
of
I'm
people.
down, but we gotta settle everything on Earth before we even leave.
Yeah,
You
so
know
it's
what I'm
not like-
saying?
Yeah. So which was an interesting thing. So when NASA gives grant money for research studies, they have to specifically sign a contract that states that they will not talk to any foreign agent of another government about the research they're conducting. That's a specific NASA thing.
Yeah.
The DoD doesn't necessarily require it. The NIH doesn't necessarily require it, because when you think scientific community, you're like any advancement in science that can better serve humankind or just the earth in
Mhm.
general should be shared, right? That was like Tesla's whole thing with
Yeah.
wireless electricity. It should be free because the people deserve to have it that are here on earth, right? Nobody should have to pay for it. I created this science. This science is before you. At that time, he thought that it worked pretty well. But just that fact, like, science should be shared. And
I think what I meant is we have to figure everything out on Earth before we leave, as in like everyone's roles. So like
Yeah.
we have to.
I
vote.
thought you were like Earth needs to get their shit together before we can leave.
No. I
That
just
would
meant
be
like
great.
we have to vote in the leaders. Like we have to have everything settled before we leave because I'm not getting into arguments on a fucking spaceship.
Yeah, no.
All
So this was
right?
already predetermined by NASA. You just need to fulfill like your role.
So who's
right, like-
so who's the impartial person? So with my thing is
It'd
whenever
be
you do
a board that was elected.
No, I
when-
mean,
during the
I need
selection person.
I need like one or two impartial people that are coming with us. You know what I mean?
Oh yeah.
Maybe they even have firearms. I'm talking like
He wants to take guns.
I mean, you never know when you're
I'm
gonna come
talking
against
about-
The
I
Second
guess-
Amendment never dies.
No. I'm talking about like that would be for safety. Like
Against the
Yeah.
Martians.
they are just completely impartial. They have the most integrity that they've ever seen in a person. They have firearms for worst case scenarios, right? They don't get to vote if there's like a voting thing that we're going to do out there. I mean, like they are there strictly as impartial
Yeah.
party, and maybe there's two so that they're not alone.
Are they supposed to be like what, judge, jury, and executioner for the
Yes.
group? Or
Yes,
oh,
that's kind of what I'm getting at.
okay.
So
Do you want a judicial system or a judicial person there?
two, I would say two. I think two would be the best, right? One
Well,
person
you
is
would
too
need
much
two
power.
of every position, though. Here's the thing:
Three.
You would need three.
Yeah. You can't
Oh.
have two people voting. One
Oh,
person could say
true.
no, one could say yes. You need a third.
So three.
That's why Supreme Court's 7 people. So you can't ever have like a middle ground split.
So three armed, truly just there for their own whatever reasons with firearms that can enforce whatever needs to be enforced when you're out there because you have nobody else. And what if something did happen where someone went fucking crazy and started just murdering people? You got to have someone that can protect the group.
That's why they put duct tape on every spaceship that has ever left Earth. Not necessarily to help repairs, but also to restrain those who may need it.
You still have to get them. That's the problem with that theory,
Yeah.
though. You have to be able to get that person.
Now, here's the thing: you're on Mars and you have somebody convicted of murder. Are they really paying to ship that person back, or are they just taking care of it there?
Oh, you're taking care of it there. That's why you need
Yeah.
judge, jury, and
Yeah.
executioner there.
Yeah.
There ain't no going back to Earth, buddy. If you have your three people, you can even let everyone else vote, I guess, if that's what you want to do. But your three people are like your final say so, and they.
If we start colonizing on outer space, do we have to have interspatial law set in place?
Yes.
So it'd have to be a separate set of rules.
Just a basic set of.
Yeah.
They'd have to be rules, not guidelines. This isn't the pirate code.
Mhm.
But they would have to be rules that everyone would have to follow. And then you can make your own choices based off of your inflection or whatever the hell you got going on your particular planet.
Okay.
Here's the interesting loophole in all that, though. So in 1967, there's like an international space law that was created. So individuals cannot or will not ever be able to own something, right? Let's say a mining company all of a sudden had a bunch of money to go mine an asteroid. They could hollow out the entire asteroid and strip it of every chemical as long as they left the core and they're like, yep, we didn't touch it. Well, I mean, you kind of ruined it at that point, but it was never theirs, but they can take the minerals from it.
But that's an Earth law, bro. What if there is another thing out there that they're like, yeah, that's not a thing, dipshit.
Yeah, because same thing like yeah, in
I'm
Earth law,
stealing.
you can't militarize stuff in space.
Again, Earth law.
Yeah.
But that,
So then
that also changes because now we have a space race for who can get a military force.
We have a space force. We are
Yeah.
militarizing space.
Yeah.
yeah, they're more of satellites.
Okay. Dude.
Yeah, but I mean, I'm assuming the next step is to put a base in. Do you know how strategically advantageous it'd be for them to have a base on Moon?
Mexico?
A
the
base
moon.
on Moon. Moon base.
Base on the Moon.
We call it Moon base. Hey, do you guys know what the name of our solar system is?
The solar system?
It is.
Yes.
Yeah.
Yeah. So that shit kind of blew my mind too, because we always call it the solar system, but we call
It's
other
just-
things solar systems too.
Mhm.
Yeah.
But it's because
So-
our sun is called Sol.
Yeah.
So it's the solar system. I was like, oh my god.
Yeah, because basically our
Duh.
cosmic address is Earth, comma, solar system, comma, Milky Way galaxy,
Mm.
and that is our address. Like, if you want to find us, just come to Milky Way galaxy, solar system, Earth.
If you hit the black hole, you've gone too far.
You've gone way too far, and I'm sorry, you're not coming back.
Third arm on the right.
Yeah, we are, aren't we?
I don't know.
I think we're on, because there's 2 arms, not 3. So we're on one of the. We're pretty far from the center. We're nowhere near.
Well, we're so we have our solar system, Milky Way,
Mm-hmm.
Linakia, I think is how you pronounce it.
Mm.
Lan
Nakia.
Linakia. It's our address.
Cosmic address.
Seems like something you'd have to do for like 8th grade.
The
Oh wow! So
Linakia supercluster.
yeah, so it looks like there's a lot more. So so it's planet Earth, solar system, Oort cloud, local interstellar cloud, local cavity, Orion arm, Milky Way, local group, Virgo supercluster, Linakia supercluster, and the universe.
They just keep putting everything in like bubbles, basically.
Pretty much, it's just like
But
expanding circles.
Mhm.
the map of Linakia, or however you pronounce it, is
Mhm.
kind of cool to look at. They have like a 3D rendering on the Wikipedia page for the supercluster.
So a supercluster, I'm assuming, is just a gigantic cluster of just galaxies, right?
Yeah, but
Solar
it-
systems.
it's kind of cool
No, it'd be
to look at
galaxies.
though,
Oh, is it galaxies?
Mm-hmm.
because it's like clusters of stuff just everywhere.
Yeah, it's basically like you take a graph and you just have a bunch of dots everywhere, and those dots are creating like a neighborhood, and that's what that is. So like NGC 7172 group, and so there's the Pavo Indus supercluster, the Centurious supercluster, the Southern supercluster, and then the Hydra supercluster.
Hydra.
So they've
Yeah.
like kind of, and then there's local groups beneath them. So
Yeah.
So I hate doing it. We're out of time, boys.
damn,
I know.
It do be that
Space
time.
2. It do be that
Yeah.
time.
it do be that time.
We might have to do Space 2, a further venture into the exploration
Yes.
of mankind's unknowns.
Yeah, absolutely. I love
Yeah.
space. Guys, thank you so much for listening. Like I said, we are not experts in this matter, but we just love space and everything there is to know about the unknown. And some things that we said are probably incorrect. Feel free to let us know if there's anything that we said that was incorrect with a link with the correct information, and we will redact it. Thanks again for listening, and then follow us on social media.
Yes.
Say hi to us, please.
Tell your friends, tell your family. Tell that creepy uncle that you don't like looking at in the eye.
Yes, especially him. I want to talk to him. I want him on the podcast. Creepy Uncle Joe. I want him on the podcast. He doesn't have to be a Joe, but as long as he's creepy.
Tim, thanks for being here.
Yes, thank you for having me again.
Thanks for all the
I enjoyed it.
listeners for hanging out with us tonight. I love it very much. All your support has really been showing. We just keep blasting out the news to everybody on all of our social medias. Our YouTube is up and running now. So if you are a
subscribe.
Tenured listener, you can actually go to the YouTube now and watch the actual videos and see our reactions in real time, which most of them are hilarious.
Yes, we are all ugly, so you get to just look at our faces as we
Speak for yourself.
Yeah, we got 2 gingers, a brown guy, and a Viking in the room.
Yes.
A Northman. This is an interesting group that you're gonna see. Yeah, please don't roast us too hard. I would appreciate it.
I'll take the roast.
Yeah. It's just content.
Yeah, it's just content.
Oh.
But no, seriously, like, follow, subscribe on anything that you want to. Let everyone that you care about know about us. Blast us out on your social media if you actually enjoy a particular episode. We could use any and all publicity that we could get right now. So I know me and Raj are very grateful for those that are listening every day. We're at 118 downloads today. We'll probably break that 120 mark by the time we release this episode. So seriously, y'all rock. Canada, UK, Germany, we have it all. So other than that, I'll leave you guys all with our normal
Trademark.
trademark, man. Stay ordinary, my friends.